Hey guys, so this is just this week's recording of the questions we ran through on Monday. Same thing as always, if I've forgotten anything, let me know. And if you have any other questions, I can send them on to you. So yeah, let's get started. So we did a bunch of coordinate geometry of the line and a lot of triangles last week. So um, we'll keep going with the stuff we were doing on the line, and then towards the end, we were doing orthocenters and things like that. So we'll get onto that. But very first question. Points 8, -4, and b, -3 are endpoints of the line segment AB. Find the coordinates of point C, which divides AB internally in the ratio 4:1. So this is our equation in our logbooks for dividing a line in the ratio AB. Um, so so our points are 8, -4, and -3, 1. So it helps always if you draw it. So this will be 8 -4 -1, 3. And we want to divide it into the ratio 4:1. And so our ratio is AB, so A here is going to be 4, and B is going to be 1. And our x1, x2, and y1, y2 are just going to be our points on either end. So B is 1, so we're going to multiply that by x1, which is going to be 8. So 1 times 8 plus A is going to be 4, and we're going to multiply that by x2, so it's going to be -1. So that's 4 times -1, and all that's going to be over b plus a, so that's just 4 plus 1, so that's 5. So it's going to give this to us. We're trying to find the coordinates of the point C, which divide the line. So this here is going to be point C, and all this we're going to plug this into our calculator. That's just going to be a number. That's going to be our x coordinate of our point C. So this is going to have x, y. And so now we're going to find the y coordinate. So we're going to do b times y1. So I got rid of it there. So b was 1 here. So b times y1 is -4. So 1 times -4. And then we're going to add a is 4 times y2. Here is going to be 3. So 4 times 3. And all over, same thing. 4 plus 1 is 5. So we're going to put all this into our calculator. And it's just going to spit back out a point. So if we do 8 minus 4 over 5, and -4 plus 4 times 3 is 12, all over 5. And we keep going, so that's just 4 over 5, and 12 minus 4 is 8, 8 over 5. So these are the coordinates of our point C. So this is x, y. And that's your question done. So yeah, lots of things I was saying during the week, lots of things for coordinate geometry are lots of formulas. There are ways, like I was doing there, if you have your 2 points and your point dividing it, and you have A, B, if you multiply this one by the x coordinate, then this one by the x coordinate, or no, the x coordinate here, then this one by the y coordinate, and this one by the y coordinate, you'll get the same answer, but it's the exact same. It's just a way of remembering the formula. It's the exact same thing we're doing here. So yeah, always make sure you have your logbooks handy, and just recognize how to plug into the formula. But yeah, on to the next question. So next question, it says the coordinates of 3 points A, 2 minus 6, B, 6 minus 12, and C minus 4, 3. Find the perpendicular distance from A to BC. Based on your answer, what can you conclude about the relationship between the points A, B, and C? Okay. So if you go to your log tables, this is your equation for perpendicular distance from a point to a line. But you can see from the question we have 3 points. We don't have a point in a line. So we're going to have to create the line BC and then find the perpendicular distance from A to BC. So how are we going to create the line BC? Well, to create a line, 2 things you need a slope and a point, because then we plug it into y minus y1 equals m times x minus x1. So we're going to need the slope here, and we're going to need the point x1, y1. So how are we going to find the slope? Well, that's going to be the slope between these 2 points. And we're going to have to use another formula. So our slope formula is going to be m equals y2 minus y1 over x2 minus x1. So that's going to be, if we set this to x1, y1, and this to x2, y2, So y2 is going to be 3 minus 12 over minus 4 minus 6. So it's going to be 15 over minus 10. So it's going to be minus 3 over 2 is our slope. And we can choose either one of these points. So let's just choose 3 minus 4, because actually, no, let's choose minus 6, 12. Seem like easier points. So if we set into our formula, y minus 12 equals minus 3 over 2 times x minus 6. So that's going to be y equals minus 3 over 2x. The minus 3 over 2 times minus 6 is going to be plus. So this is going to cancel with that 6, and you're going to be left with 3 there, and the 3 times 3 is 9. And then we're going to bring this 12 over. So this is going to turn into a positive 12, but then when we bring it over, it's going to be a negative 12. So our line is going to be minus 3 over 2x. 9 minus 12 is going to be minus 3. And so this is our equation, the equation for the line BC. And now we're going to need to find the perpendicular distance from A to BC. So we're just going to plug it into our formula. First let's get the line in the form it wants. So it wants ax plus by plus c, and we have it as y equals mx plus c. So let's bring this 3 across and then multiply by 2 and bring the x across then. So this means that first let's bring the 3 across, minus 3 over 2x, and we can multiply by 2, so that's 2y plus 6 equals minus 3x, and that's going to be 3x plus 2y plus 6 is going to be equal to 0. So this is going to be our A, B, C, and our point is going to be x1, y1, that's going to be A, so it's going to be 2 minus 6, so x1, y1 is going to be 2 minus 6. Let's just sub into our equation. So it's ax1, well, first of all, it's absolute value, and here is going to be 3, x1 is going to be 2, so it's 3 times 2, plus by1, so b is going to be 2 times y1 is going to be minus 6, and then we're going to add c, and c here is 6. Then we're going to do the absolute value, and we're going to put this over the square root of a squared plus b squared, and a and b here are 3 and 2, so it's going to be the square root of 3 squared plus 2 squared. And now we can just put all this in our calculator. So 3 times 2 is going to be 6, and minus 12 plus 6, and that's going to be root 9 plus 4. So it's going to be absolute value of 0 over square root 13. And so the absolute value of 0 is just 0, so it's 0 over square root 13. And you can see that any 0 divided by anything is just 0. So the perpendicular distance from A to BC is equal to 0. And what it's asking us is, based on your answer, what can you conclude about the relationship between the points A, B, and C? Well, if I just draw a quick thing here, if this is B, this is C, and this is A, what we were doing was we made a line BC, and then we were trying to find the perpendicular distance from A to B, and we were trying to find a number for this value. What we actually got was 0, so that means that if this is our line BC, our point A is actually going to sit on that line. And so what we would call that is it's going to be A, B, and C. A, B, and C are all collinear. There's 2 L's. Yeah. And that's the conclusion they want you to make, and that's the question done. So the perpendicular distance from A to BC was 0, and based on your answer, what can you conclude? They're collinear. And so that's the question done. On to the next question. So the next question says the line M which is 2x plus 3y plus 1 equals 0, is parallel to the line n, 2x plus 3y minus 51 equals 0. Verify that a minus 2, 1 is on M. So how do we verify a point is on a line? Well, we're just going to sub in, if this is x, y, we're going to sub in x, y. Everywhere we see x, we're going to sub that in. Everywhere we see y, we're going to sub that in. And we're going to see if it satisfies the equation. So we're going to see if this side is equal to this side. And so we're going to see if 0 is equal to 0. So let's do that. So everywhere we see x, we're going to sub in minus 2. So that's 2 times minus 2 plus 3 times y is 1, and then plus 1. And we can see that that is equal to minus 4 plus 3 plus 1. So that's minus 4 plus 4, and that's equal to 0. So 0 is equal to 0. So our equation is satisfied, and that means A lies on the line M. So that's all you have to do for the part A. Part B says find the coordinates of B, the point on the line N closest to A, as shown below. So we're trying to find the coordinates here of B. So if we label this xy, we're trying to find those coordinates. We're trying to find xy. B sits on the line N. We know the points for A. That's minus 2, 1. And you can see here that there's a big fat square there. That means it's perpendicular. So alarm bells should be going off in your head. This is the perpendicular distance. So if we can find the perpendicular distance from this point to the line N, then we can find the distance between B and A, let them equal to each other. So if we say AB is the distance from A to B, so we can find AB, we can find the perpendicular distance, and we can let AB equal the perpendicular distance, because they should be the same number. You can see here, distance from A to B is the same as the perpendicular distance from A to N. So if they're the same thing, then we're going to see what we have. We're going to have some variables in terms of x and y, that kind of thing, and we're going to solve them. So let's hop right into it. So I'll clear a bunch of this off. So first thing we wanted to do was find the perpendicular distance from A to B. So we know this was from A to the line N. So we know A was minus 2, 1. If we scroll back up, we know N is 2x plus 3y minus 51 equal to 0. So if I go up here and I actually copy this, if you go to your log tables, you're going to find this formula. So distance from this is minus 2, 1, and our A was 2, our B was 3, and our C is minus 51. So let's just sub straight in. A is 2 times minus 2, plus B times y1 was 3 times 1, and then C was minus 51, and that's the absolute value. And then we're going to square root A squared is 2 squared, B squared is 3 squared. So if we plug this into your calculator, that's minus 4 plus 3 minus 51, absolute value over root 13. And so this is minus 1 minus 51, so that's minus 52 absolute value over root 13. But the absolute value here means that anything inside the absolute value can't be negative. So we're going to swap this to positive 52 over root 13. So this is our perpendicular distance from the line A to N. And now we're going to want to find the distance from A to B, and then let it equal to 52 over root 13. So let's do that. So I've just cleared up some things and just rewritten. So this here is our perpendicular distance, what we wanted up here. And so now we want to find the distance from A to B, let it equal to 52 over 13, and we're going to be able to find the coordinates of B. So this here, if you go to your log tables, is the equation for the distance between 2 points. So we know the point A, that's minus 2, 1. We don't know the point B, that's what we're trying to find. So let's just call that anything. Let's call that xy. We do know that B sits on the line N. So we do know we have a way of finding x and y. If we take our equation for our line N here, and if I just do a little aside up here, so if we get x on its own, that's going to be minus 3y plus 51 all over 2. So that's how we can find an x value. We could do the same. We could get y on its own and get it in terms of x. but we're going to need this later. You're going to see why. But this, I'm just getting this out of the way first because I know we're going to need it later. So let's find the distance from minus 2, 1 to xy. We know how to do that. So distance from A to B is going to be square root of x2 is just x, found up here. x1 here is minus 2, so that's minus minus 2, then that's squared. Then we're going to add y2 is just y, and then we're going to minus 1, and then we're going to square, and then square root the whole thing. So that's going to be equal to square root of x plus 2 squared plus y minus 1 squared. And we can just let that equal straight away to 52 over 13 because we said AB was equal to this, and if AB is equal to the perpendicular distance, it's equal to this. So to make this looks a bit ugly on the left-hand side, so let's get rid of the square root if we square both sides. So that's x plus 2 squared plus y minus 1 squared is equal to, if you plug this into your calculator, that's actually 4 root 13. And so then if we square that, that's just going to be 16 times 13, which is, hold on, I get my calculator out. 16 times 13 is equal to 208. So now, you see why I needed to go back up and get y in terms of x here? Because if I bring this down, copy, paste, I'll just leave this over here. Because you see here, we have too many unknowns. We have two unknowns, and they're both equal to the same thing. So we have no way of, if we get x on its own here, we're just going to end up with a y on this side. And if we get y on its own here, we're going to end up with an x on this side. So we need to sub in or cancel one of the y's, sub in one of the x's, something. We need another bit of information. And this is going to be our information up here. We know that point B sits on the line x, and we have a way of finding either y or x from this equation up here. So that's what I did. I found x in terms of y, and now I can just sub in. Anywhere I see x here, I can sub in this. So that's minus 3y plus 51 over 2 squared plus y minus 1 squared is equal to 208. So if I just make a bit more space. So this is going to be minus 3 over 2 y plus 51 over 2 squared plus, and we know how to square this, so that's just y squared minus 2y plus 1 is equal to 208. Then we're going to square this here. So we're going to square the first. Minus 3 over 2 squared is 9 over 4. And then don't forget the y squared. We're going to 2 times the product. So that's minus 3 over 2 y times 51 over 2. And then we're going to square the last. So that's 51 squared over 4. And then don't forget y squared minus 2y plus 1 is equal to 208. So now we can keep multiplying, so that's 9 over 4 y squared plus this 2 will cancel with everything. That's going to be minus 3 times 51 y plus 51 squared over 4 plus y squared minus 2y plus 1 is equal to 208. So I'm just running out a little bit of space, so I'll just, if you continue on with your calculations here, I've skipped a couple steps. This here is the quadratic you should end up with. So you should get y squared minus 26y plus 169 is equal to 0. And if we factorize this, that's y times y, 13 times 13, minus minus. So this is going to be y minus 13 equal to 0. That's going to be y minus 13 squared is equal to 0. So y here is going to be equal to 13. Well, we can even skip that stage here. If we know one of these are equal to 0, then y is equal to 13. So we know a value for y, and now we just need to go back and get a value for x. Well, we can do that, like I was saying before, we know this y, and we know x sits on the line n, and we found this. If we sub in for y here, we'll get a value for x. So it's perfect. I actually brought him down here. I'll just copy him. So if I paste this here, then if we sub in 13 for y plus 51 over 2, and we put this into your calculator, you should end up with minus 6. So your point B is going to be minus 6, 13. And that's the question done. So we did this question before, but we didn't actually use the perpendicular distance formula because we hadn't seen it yet. And the reason I did that is because I want you to see that there's lots of ways of doing this. Like this is a second way to do it. I think there is another third way if you check on StudyClix. But this is how you do it with the perpendicular distance formula. So yeah, it is a little tricky. Definitely watch me going through it. You can rewatch this as many times as you want. And if you have any questions about it in the next grind, I'd be happy to answer them. But yeah, go through it as many times as you want. Even do it out as many times as you want. See where you get stuck. Come back to the video. All that kind of thing. But yeah, on to the next question. So the next question says, calculate the shortest distance between the line 6x plus 7y minus 10 equals 0 and the point 36. So if you go to your log tables, this is your equation for perpendicular distance, and it's perpendicular distance from a point to a line. So this is perfect. We don't even need to change anything like we did in the very first question. We don't need to find a line, that kind of thing. We can just plug this point and this line straight into our equation. So here A is going to be 6, B is going to be 7, and C is going to be minus 10, and x1 is going to be 3, and y1 is going to be 6. So our equation is A, which is 6 times x1, which is 3. Then we're going to do B, which is 7 times x2, or y1, which is 6. And then we're going to plus C, which is minus 10. And all that's going to be over A squared is 6 squared plus B squared is 7 squared. So that's going to be 18 plus 42, then minus 10. And all that's going to be over square root of 36 plus 49. So that's going to be 42 plus 8 is 50, all over the square root of 70, 85. Yep. So that's going to be, now this is the absolute value, but there's no negative in there, so it doesn't even matter. It's just 50 over the square root of 85. I think if you put this in your calculator, it might give you back something else. You could just leave it like this. There's no reason they wouldn't give you any points. But if I just put this in my calculator, I'll see. So 50 over, it's kind of different. You can get it as this. So 10 times root 5 over root 17. But I'd be more than happy to just leave it like this. So then in the ground, we started looking at the median triangle and all its centers and that kind of thing. So you have all the printout, and in this section, I'll just be running through what it says on the printout, just to go back over what we said. But basically, but make sure to hang on to those sheets. It tells you how to make them, that kind of thing, because that is examinable, how to construct them. But okay, so basically, there's 4 centers to a triangle. Well, there's 4 that you need to know about. There's one called the centroid. There's one called the incenter. There's one called the circumcenter, and there's one called the orthocenter. And you need to know how to construct all of them. And as you'll see up here in this question, you don't need to construct it, but you need to know what it looks like. Or actually, you kind of do need to know how to construct it. But anyway, I'll just run through them. So centroid, what you're going to do is you're going to connect each corner to the midpoint of the line. So you see here, this side is actually the same length as that side. And you're going to connect this corner to the midpoint. And you can do all 3, but once you get 2, where they cross is going to be where the third one crosses as well. So orthocenter, connect the triangle or the corners to the midpoint of the sides, and that's how you get the centroid. for the incenter, you're going to just bisect the angles. So you see this angle is the same as that angle. You're not going to do anything else. You're just going to go through the corner and bisect the angle. And another thing that the incenter does is that if you draw a circle around this point here, it's actually going to sit perfectly inside the triangle like this. So if ever a question asks you, like, find a point that's equidistant from all three sides, this is the point you're going to find. You're going to find the incenter. So usually what they do is these will kind of be described as roads. So if this is a road, that's a road, and that's a road, and they want like a garage equidistant from all roads, they'll ask you where would you put it, and you'd say the incenter of the triangle formed by the roads. Okay, so on to the next one. So the next one is similar. It's the circumcenter instead of the incenter, and it's similar because instead of a circle inside the triangle now, it's a circle outside. It doesn't have to be. It has to be outside. Yeah. So it's a circle that connects all 3 points of the triangle. So this circle is equidistant from all 3 corners, not all 3 sides. So this circle is equidistant from all 3 sides. This circle is equidistant from all 3 corners. So what they do here is they say this is a town, this is a town, this is a town. Where would we, if we wanted to put a hospital equidistant from all 3 towns, where would we put it? We'd put it in the circumcenter so that it's equidistant from all of them. But how do you find it? So similar to here, so to find the incenter, you bisect the angle and go through a corner. Here, you don't go through a corner, but you do bisect an angle. So imagine this is your angle here, that's 180, and this is your midpoint. You're going to bisect the angle through the midpoint, but every time you bisect it, obviously it's going to be 180 every time, so it's always going to be 90. So go perpendicular to the midpoint and make a line through there, and where they intersect is going to be your circumcenter. And finally, the last one, orthocenter, connect each point to its opposite side perpendicularly. So here, it's kind of similar, very similar to the centroid. So the centroid, you connect a corner to the midpoint, but the orthocenter, you connect a corner to a side, but not at the midpoint. You just want to connect it perpendicularly. So instead of connecting at the midpoint, now we're just connecting at 90 degrees. And so that's the difference between the orthocenter and the centroid. Some people get it mixed up. There's no real application to the orthocenter. It's just a geometrical object. But it does get asked in exam papers like we'll see up here. So if I go to the very first part, so it says A is minus 3, 4, B is 0, minus 5, and C is 3, 4. These are the corners. Find the equation of the line through B, which is perpendicular to AC. So we want to find the line that goes through B and ends up 90 degrees to AC. Okay. Well, first of all, what are they asking? We're trying to find the equation of a line. So what we need for that is we need a slope and a point. Well, we have the point. We have the point B. That's the point we're going through. We just need the slope of this line here. And how are we going to find that? Well, we know because it connects at 90, the slope of this line is actually going to be perpendicular to the slope of this line. So if we can find the slope from A to C, this line here through B is going to be perpendicular to the slope, that slope. So let's go ahead and do that. Let's say M1 is going to be the slope from slope with an EAC. And we know that's going to be y2 minus y1 over x2 minus x1. And that's going to be, so if this is x2, y2, x1, y1, so y2 minus y1 is going to be 4 minus 3. So 4 minus 3, 3 minus, and then x2 minus x1 is going to be 3 minus 4. So it's going to be 1 over 7. And so we know M2 is going to be the slope of our line through B. Let's just say B. And we know it's going to be perpendicular to this slope here. So when we're writing a perpendicular slope, we want it to flip it upside down and then change the sign if that's plus or minus. So we're going to flip this upside down, so that's just going to be 7 over 1. And then this is a plus here, so this is going to be a minus here. So our slope of b is going to be minus 7. Okay, so we have our slope and we have our point. So now we can make the line. So that's y2 minus y1 equals m2 times x minus x1. y1 here is minus 5, so that's minus minus 5. Our slope was minus 7. And our x1 here is 0, so that's x minus 0. So y is going to be minus 7x minus 5. And that is the equation of B. So this is the line through B perpendicular to AC. And that's all you need to answer. But moving on to the next part. Hence or otherwise find the orthocenter of the triangle ABC. Okay, so now this is what I was saying before. You need to know what the orthocenter is or how to find it. So it has given you a hint. It's already given you the line B, which goes from a corner perpendicular to a side. And the reason it's done that is because that is how you find the orthocenter. If we go back to our handout here, we go from a corner, we go from a corner to a side, and then we go 90 degrees. So we'll use the same letters here. So this is B. So we found that one. Now we just need to find from a corner to a side, get 90 degrees, and then find where they intersect. And that will be the orthocenter. So let's do that. So if we have this here, this was y equals minus 7x minus 5. Let's just choose any of them. So let's do from A. So it's the exact same construction. We can find the slope from here to here. This is going to be the opposite slope, and then we're going to use the slope and a line to get our equation. So let's find the slope of C to B. That's going to be y2 minus y1 over x2 minus x1. That's going to be 4 minus minus 5 over 3 minus 0. So that's going to be 9 over 3. That's going to be 3. And so our slope of the line that goes through A is going to be flip it upside down and then change the sign. So it's going to be 1/3. So we have our slope of this line and we have our point. So now we can make our equation. So the equation of A is going to be y minus y1 equals m times x minus x1. That's going to be y minus y1 here is 3. Our slope is minus 1/3. And x minus x1 here is minus 4. So it's minus minus 4. So that's going to be y equals minus 1/3 x minus 4 over 3 plus 3. So that's going to be 1/3 x plus 5 over 3. And so this is our equation for A. And now we need to find where they intersect. That's going to be our orthocenter. So we have our two equations. If I copy and paste them over here. And so we know when we're finding the point of intersections, if we let them equal each other here, we can get rid of the y's and find the x's. So that's 7x minus 5 equals minus 1/3 x plus 5 over 3. And we'll bring the x's to one side. It's plus 1/3 x equals 5 over 3 plus 5. So that's going to be minus 21. That's going to be minus 20 over 3x plus 15 plus 5. That's 20 over 3. So x is just going to be minus 1. And we're going to just sub back into any of our lines up here. So y is going to be minus times minus 1 plus 5. So it's going to be 7 plus 5. That's going to be 12. So our point here is going to be, our orthocenter is going to be minus 1, 12. So that is the question done. Not done, sorry, last bit. Find the midpoints of A, B, AC, and show the origin is the circumcenter of the triangle AB. Okay. Well, okay, we're going to find the midpoints of A, B, and AC. Sorry, I've just made a mistake up here, so this should actually be minus 5. So that would be 7, minus 5, and that'll be 2. So our point is going to be minus 1, 2, which is going to be minus 1, 2 there. So this here is our, I'll call that just ortho. So that is our orthocenter. But anyway, back to the question we were doing. So it says find the midpoints of A, B, AC, and show that the origin is the circumcenter. Okay, so we have an equation for the midpoints. That's kind of easy. So the midpoint of AB is we just take the coordinates of A and B and find the midpoints. So if we call this x1, y1, we call this x2, y2. So x1 plus y1, so it's minus 4 plus 0. And then we're going to divide that by 2. Then we're going to do y1 plus y2, so that's going to be 3 minus 5, and it's going to be over 2. So that's going to be the point minus 2 and minus 1. So that's the midpoint of AB. Midpoint of AC is going to be, if we call this one x1 now and y1 instead of A, so it's going to be 3 plus 0 over 2, and that's going to be 4 minus 5 over 2. So it's going to be 3 over 2 and minus a half. So that's the midpoint of C. And show that the origin 0, 0 is the circumcenter of the triangle ABC. Okay, so how do we find the circumcenter? Well, we should go down, it's right here. So what we do is we take a line perpendicular at 90 degrees of the midpoint. So we found the midpoints of AB and AC. Now we just need to put lines through them 90 degrees. Where they intersect is going to be hopefully the origin, because that's what they want us to do. But let's do that. So we found the midpoint AB. That was minus 2, minus 1, so that's midpoint there. And the midpoint of AC is going to be somewhere here, I think. Is what they, yeah, 3 over 2 and minus a half. So now we're going to send lines like this at 90 degrees. So how we're going to do that, we're going to get the slope from AB, slope, and go perpendicular. And then we're going to get the slope from AC and go perpendicular. Make two equations, blah, 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 kind of same thing. We're doing a slope and a line. Slope and a point gives you a line. So let's do that. Well, we already have the slope. Here we go. We have the slope of AC. Oh no, we don't need that. So we have the slope of, what do we already have the slope of? We already have the slope of CB. That's 3. So we can use that. So slope CB is 3. So we know this slope here is 3. So this slope here is going to be minus a third. So let's call that perpendicular, to say. Slope a third. Now we're just going to want to find the slope of AB and then go perpendicular. So AB will be slope AB is going to be y minus y1 over x2 minus x1. So it's going to be, if we call this x1 y1, x2 y2. So it's going to be minus 5 and minus 3 all over 0 minus 4. So it's going to be minus 8 over 4. That's going to be minus 2. So the slope perpendicular is going to be a half. Okay, so this is our slope perpendicular to BC. So let's go from here. Oops. Yeah, there you go. So let's go from here. So this is our slope for this. We have our point. So our midpoint of BC was -2, -1. Oh no, sorry. Our midpoint for BC was 3/2 and -1/2. So y minus 3/2 is equal to -1/3 times x plus 1/2. So y equals -1/3 x minus 1/6 plus 3/2 -1/3 x plus 8/6. That's -1/3 x plus 4/3. So this is our equation for, let's just call it line 1. Now we're going to, this here's line 1. Now we're going to find line 2 and let them equal each other. So same kind of deal. We know the slope. We know the midpoint is -1, -2. So let's go from here. Y minus -2 is equal to 1/2 times x minus -1. So that's y equals x/2 plus 1/2 minus 2. So that's x/2 minus 4/2 plus 1 minus 3/2. And now this is going to be line 2. And we're going to let them equal each other to find the point of intersection. 4/3. And hopefully this should be 0, 0. So -1/3 x plus x/2 is equal to -3/2 minus 4/3. So that's going to be 2 minus 2/6 x plus 3x/6 is going to be -9/6 minus 8/6. So if we multiply everything by 6, that's going to be -2x plus 3x minus 9 minus 8. So it's going to be x is equal to... Okay, well, I've seem to have made a mathematical slip, but you get the idea. I won't have time to finish it, but you know what we're doing. We're getting the slope perpendicular to the midpoints. We're going to let them equal each other, and this is going to be where they cross at 0, 0. Because there's so many calculations, it will take me a while to go back and find where I've gone wrong. But that's okay. As long as you understand the process, I'm okay with that. The numbers don't matter too much at this point. If you don't understand the process, let me know at the next grind, and I'll gladly run through it again. But yeah, so that's all the questions we ran through this week. And yeah, I'll finish here. Any questions, let me know at the next grind. And if you have any questions you want me to send me and I'll do in the next video, you're welcome to that as well. But yeah, I'll see you guys next week.